Welcome to calculating probabilities for a normal distribution. So the idea here is we can use our density curve to calculate the probability of landing in a specific interval. So we will use the normal density curve to calculate the probability of landing in a specific interval. Technically, I should say we will use a normal density curve to calculate the probability of landing in a specific interval. It is completely possible to do this with any normal curve. Statisticians traditionally have used the z-score to standardize to a single normal density curve and then do other calculations from there. It is possible, however, to do it straight from the mean and standard deviation and without this. We're going to look at the length of newborn females again, which is normally distributed with mean 49.1 standard centimeters and standard deviation 1.9 centimeters. So we have mean mu equals 49.1 and standard deviation sigma equals 1.9. We are looking for the probability that a randomly selected newborn female is shorter than 47 centimeters. So first, let's just draw the picture. So right now we have mean 49.1, standard deviation 1.9, and we are looking at 47, which will be somewhere to the left. And we want shorter than 47. So we want to figure out the probability of being less than 47 is the area under the curve to the left of 47. So again, there are tools at this point that can be used for finding the probability straight from here. We are going to practice walking through z-score. So from here, we're going to convert to z-score. To do that, we will use the formula z equals x minus mu over sigma. So this one is in x. We are now going to convert to z. So it turns out when we convert to z, the mean always converts to 0 and the standard deviation always converts to 1. So we get a very specific curve. But it looks the same, it just is scaled differently. So this is our z-score. The mean will now be 0. When we do the mean minus the mean, we'd get 0 divided by our standard deviation. And it's our job now to figure out what z-score corresponds to 47. So we need to figure out how 47, what that becomes as a z-score. So here we have x equals 47. That gives us z is equal to 47 minus 49.1 divided by 1.9. This becomes negative 2.1 divided by 1.9. And if we do that calculation, we wind up getting negative 1.105. And we'll just go with negative 1.1. Oops, what? Okay. Well, we'll leave it at negative 1.105. Now what we can do is we can use a normal distribution calculator to calculate that probability. So this is 1, 2, 3. We will use a normal distribution calculator. I'm going to give myself some more room. We'll use a normal distribution calculator to calculate probability. So we actually have one of these in our Canvas page. I will go ahead and open. All right, I'm not sure where I stopped recording and where I started recording, so we're going to quickly go back through. Let me share the appropriate graph. So here, what we're looking at is if you go to the end of modules on your statistics page, there's a module for statistics calculations. And so one of them is the normal distribution calculator, standard normal. That's for z-score. I went ahead and typed in negative 1.105 and hit enter. And then it tells us the area to the left and the area to the right. So I'm going to switch back to my other share pause. I've drawn the picture down below, more or less. And the area to the left is 0.1346. And the area to the right is 0.8654. So for this problem we were working on, the original area that we wanted was the area to the left. So that's the one we want. And we wind up getting that the probability of randomly selected newborn female being less than or shorter than 47 centimeters in length is 0.1346. So that's sort of the basic idea for calculating probabilities. Again, this calculator tells us both the area to the left and the area to the right. Just a side note here. Note to find the probability of landing between two numbers. We have a couple of options. There is actually a calculator for doing this in Canvas, I believe, but it is not linked at the end. we can use the same normal distribution calculator we just used. If we're looking for between two z-scores, so let's call this z-score 1 and z-score 2. If we're looking between two z-scores, what we can do if we want this probability, this is the same thing as looking at the full probability to the left of z-score 2, and then taking away the small probability to the left of z-score 1. So what we can do is we can find the left area for both of the z-scores and then subtract. We do the bigger probability minus the smaller probability, and that will give us the probability of landing between the two numbers. So that is finding probability using the normal distribution, or when we have a normal distribution.